Hello friends, in today's lecture we are just going to talk about how to convert between different word lengths. Okay, bits or 16 bits. Okay, this is 1 bit. Okay, so this particular is 1 bit. Okay, and we have used 8 bits representation here in our last lecture. Now let's see how we can convert a 4-bit number into 8-bit number. Let's say I have a 4-bit number 0, 1, 1, 0. Which number is this? 6, right? Remember, from now onwards, all the computer arithmetic lectures, you have to sit in front of your computer with pen and paper. It's compulsory. Okay, so get your pen and paper and try writing everything with me. Okay, so I have used this 4 bits number. This is a 4-bit number 6. Now what if I want to convert this to 8 bits? So what I have to do is just append 0, 0, 0, 0. This is 6. Now what if I want to represent minus 6? Let's first represent minus 6 by using only 4 bits. For minus 6, again there are two methods which as we have discussed in our last lecture. First method is sign magnitude representation and second method is 2's complement representation. At first let's talk about sign magnitude representation. Okay, so for sign magnitude representation this will be 1, 1, 1 and 0. Now what if I want to convert this minus 6 to 8 bits? How will I do that? So I have to shift this 1 to MSB. So it will be 1, 0, 0, 0, 0, 1, 1, 0. This is my minus 6. Only MSB will be 1 for if you want to represent a negative number. MSB should be 1 in case of sign magnitude representation. If the MSB is 0, the number is positive. Remember that. It's actually true in both cases, in both representations, in 2's complement representation as well as sign magnitude representation. Now let's take one more example. Let's try writing representing 4 and minus 4. So this will be 1, 0 and 0, right? So the bit which at the 4th position will be 1. So this 0, and if I want to represent the 4 this same number by using 8 bits, this will be 0, 0, 0, 0. And now about minus 4. If you are using only 4 bits, this bit will be 1, this will be 1, and this will be 0, 0. If you want to represent this minus 4 by using 8 bits, then you have to shift this 1 to MSB. So this will be 1 and all the remaining bits are going to be 0. I hope that's clear how to um, change the bit lengths uh, for sign magnitude representation. We have just talked about sign magnitude representation. Now let's talk about 2's complement representation. I will just write here S for sign magnitude representation. Now let's take same numbers and represent them in 2's complement representation. Okay, so for 4 bits, this will be the 6 will be 0 1 1 0, and its 2's complement will be 1 0 0 1, and the plus 1 will be equal to 1 plus 1 is equal to 0 carry 1, and 0 plus 1 is equal to 1, and this remaining part will be same 0, and this will be 1. Okay, so this is the 2's complement of this number 0 1 1 zeros. 0 1 1 zeros 2's complement is 1 0 1 0. So this is actually minus 6. Okay, this is your plus 6 and this is your minus 6. Now we are using 2's complement representation. So I will write here T for 2's complement representation, S for sign magnitude representation. See, it's different. All the bits are different. Now what if I want to um, represent this minus 6 by using 8 bits. So what I have to do is I have to just copy this sign. I have to, it won't be like this one will be shifted here. This one will be appended. Instead of zeros, 1 will be appended if the number is negative. So this is how you are going to represent minus 6 in 2's complement representation if you want to increase the number of bits. Okay, now try the same thing with 4. Pause the video here and represent minus 4 by using 2's complement representation, and then increase the bit length. Pause the video here. Okay, now check your answer whether it's right. 0 1 0 0, that is 4. Now how will you represent minus 4 in 2's complement representation? That will be 1 0 1 1 plus 1. That will be equal to 1 plus 1 0 carry 1, 1 plus 1 0 carry 1, 1 plus 0 is 1, and this one will be as it is. So this is your minus 4. Now again, if you want to increase the bit length, this will be 1 1 1 1. This is your plus 4. And for positive numbers, it's same. It will be 0 0 0 0. So remember, when the representation method is very important. See, minus 4 will be represented like this in sign magnitude representation, and in 2's complement representation, minus 4 will be represented like this if you are using 8 bits. I hope that's clear how to convert between bit lengths. So this is all about that. We'll stop here and we'll continue our next part in our next lecture. And please keep practicing for this, and don't get confused between 2's complement representation and sign magnitude representation. These are only two methods of representations. Thank you.